In this video, we're going to go over geometric progression. So I've prepared some questions that can help us to understand this topic. It is very easy. So without wasting much of your time, we can begin. The question is saying, the first three terms of a geometric progression are, we have k plus 4, and then we also have a k there, we have 2k minus 15. So this is a sequence, remember, so which simply means that it is in the form of k plus a 4, and then we have k there, we have 2k minus 15. Now a sequence continues like that. We have other terms there. So we understand that since this is on the first position, therefore this is our t1, that is our t2, and that is our t3. Now in order for us, they have said that find the value of k. So in order for us to come up with the value of k, what you need to understand that we can use the method of finding the common ratio. So how do we find the common ratio? We find the common ratio by saying t2 over t1, which is equals to t3 over t2, like that. So we use this in order for us to come up with the value of k. So what you do, you say, you start by writing the formula first. You say t2 over t1, which is equals to t3 over t2, like that. And then you have already identified that our t1 is there, our t2 is there, and then our t3 is there. So you just substitute your values there. So our t2, it is k, over our t1, it is k plus 4, which is equals to our t3, that is 2k minus 15, and then you say over what is our t2, it is k. So since there is an equal sign, so what you do, you say you cross multiply. So which simply means that k plus 4 is going to multiply with 2k minus 15. This will be equal to k will multiply with k, so we have k multiplied by k there. And then we understand that k is going to multiply with 2k minus 15. Also positive 4, it's going to multiply with 2k minus 15, like that. And then k multiplied by k, that is k squared. So you say k multiplied by 2k, that is 2k squared, k multiplied by negative 15, that is negative 15k. And then here you're going to say positive 4 multiplied by 2k, that is positive 8k. And then 4 multiplied by negative 15, that is negative 60, which will be equal to k squared. When you reach at this point, you group your like terms. So when you group our like terms, we are going to have 2k squared minus 15k. Now 15k, as we can see, 15k and 8k can add or subtract. So which simply means that negative 15k plus 8k, it is what? We're going to have negative 7k, like that. And that will be negative 60, which will be equal to k squared. As you can see, we have something which is familiar. K squared and 2k squared, they can add or subtract as well because they are like terms. So what you do, you say 2k squared minus k squared, you have negative 7k there, negative 60 will be equal to 0. So in this case, we are going to say 2k squared minus k squared, that is k squared minus 7k minus 60. This will be equal to a 0. Now remember, this is familiar with what? F of x equal to ax squared plus bx plus ac. So this is our quadratic form that we have there. So since you have already identified that this is our quadratic equation that we have, or that we have formed. So what we do here, in order for us to come up with the value of k, we say we can use the product sum factor method, product sum and factor method, or if you want you can use the formula method, where we understand that our k can be equal to negative b positive or negative the root of b squared minus 4ac over 2a, because this is a quadratic equation that we have formed. So it's either we can use this one, or we can use the product sum factor with the factorization method that we can use there. So when you reach at that point, I'm going to use the factorization method. So you say, in order for you to come up with the product, you get the coefficient of k squared, that is a 1. So you say 1 multiplied by negative 60, that is negative 60, and then your sum, you just get negative 7 there. So that is our sum. So for the factors, we look for the numbers that can multiply to give us negative 60, but when you add or subtract, they will give us negative 7. So what are those numbers? In my case, those numbers, it is 5 and negative 12. 5 multiplied by negative 12, you can even use your calculator to confirm. So 5 multiplied by negative 12, that is negative 60, and then 5 minus 12, that is negative 7. So what you do when you reach at this point, you're going to substitute these factors with the sum there on the question. So you're going to say k squared plus 5k. I've gotten this 5k there, and then you're going to have negative 12k, which is that negative 12k there, negative 60, which is equals to 0. And then when I reach at this point, I'm going to factorize, and then by grouping these, I'm going to look for what is common. So for what is common there, it is a k. Then I'm going to say k into k squared, it is a k. K into 5k, that is positive 5. And then what is common there, it is negative 12. Negative 12 into negative 12k, that will be k. Negative 12 into negative 60, that will be positive 5. And then since these are the same, I'm going to get 1, and then I'm going to combine these. So when I reach at that point, I'm going to say k minus 12, and then I'm going to have k plus 5 will be equal to 0. Remember, this is equals to 0. Now when I reach at this point, I'm going to separate. I'm going to say k minus 12 is equals to 0. Also k plus 5 is equals to 0, like that. So k will be equal to, when it jumps to the other side, that will be positive 12, and then k will be equal to negative 5, like that. Now we have two values. You have 12 and negative 5, but in the question they have said that k is a positive integer. So what you do, since they have said that it is a positive integer, so you say therefore your value of k will be equal to 12. You can't get negative 5, so you can just say discard, because it is the one which is not needed in the question. Now that's how you come up with the value of k. Now part B is saying Part B is saying list the first three terms of the geometric progression. So we already have the terms, which is k plus a 4, and then we have k, and then you have 2k minus 15, and then this continues like that. So we have to list the first three terms. Now what are those first three terms? You have this term, that term, and that term. So what you do, since you have already come up with the value of k to be equal to 12, so you just substitute the value of k with the on the terms that you are able to see there. So what you do, you say 12 plus 4 comma 12 and then you have 2 12 as well, negative 15, and then it continues like that. So you say 12 plus 4, that is 16, comma a 12, comma 2 times 12, that is 24, minus 15, and then it continues like that. So we are going to have 16 comma 12. Now 24 minus 15, that is a what? That is a 9. You can even confirm using your calculator. So we are going to have a 9 there, and then it continues like that. So that is your answer, because they just wanted you to list the first 3 terms. So we have 1 2 3, that is our first 3 terms, like that. And then see, they are saying find the sum to infinity. So how do you come up with the sum to infinity? This is very easy as well. So what you do, you just have to remember this formula in terms of finding the sum to infinity. So the sum to infinity with the symbol of infinity, it is equals to first term over 1 minus r. So when finding the sum to infinity, our common ratio can never be greater than 1. That's what we have to understand. So when we reach at this point, we say we have to find the value of r, which is equals to what? T2 over T1, like that. So you say your common ratio. Now T2, you just get this, you have a 12 there, over our T1, it is 16. So our common ratio will be, now we look for the number that can enter into 12 and 16. What is that number? That number is a 4. So 4 into 12, it is 3. 4 into 16, it is a 4. So which simply means that your sum to infinity will be equal to our first term, it is what? 16. So you put 16 there, over 1 minus 3 over a 4. So your sum to infinity will be equal to, now when we say 1 minus 3 over 4, you can even use your calculator. So this, it is what? It is you have a 16 up there, over 1 over a 4, and then your sum to infinity will be equal to 16. You understand that this line, it is same as division, so we are going to have 1 over 4. So in order for you to come up with multiplication, the denominator becomes the numerator, and then the numerator becomes the denominator. So this is same as over 1, and then this will be equal to 16 multiplied by 4, that is 64. So you say 64 over a 1 multiplied by 1, it is a 1. So this is same as 64. Just that is your answer for the sum to infinity. Very easy and direct and straightforward.